vapor pressure in this particular module of the chapter Solution and Colligative Property. Let's see what exactly you mean by lowering of vapor pressure. Let us consider a container where this container consists of a pure volatile solvent. And let me say that the vapor pressure of this pure volatile solvent is given symbolically as P01, where 1 is nothing but the symbolical representation for a solvent, and that raised to naught simply means that it's pure. So vapor pressure of pure solvent is P01. Now we are supposed to have a solution, and this solution is precisely made by adding a non-volatile solute. So when a non-volatile solute is added to this pure volatile solvent, you get a solution. Now in case of the pure volatile solvent, the entire surface is completely occupied by the solvent. It simply means that all the particles present over there are contributing to the vapor pressure. Rather, all the particles present on the surface are first of all of the solvent, and all of them are contributing to the vapor pressure. But if you see in case of solution, that is not the case. First of all the particles present on the surface, they are not of solvent. There are some particles which are out of solute. So all the solvent particles definitely are contributing to the vapor pressure, but the number of solvent particles over here are less as compared to that of the pure volatile solvent. So from here I can easily conclude that the rate of evaporation is more in case of pure volatile solvent, and the rate of evaporation is relatively less in case of the solution. So I can once again conclude that the vapor pressure of the solution is less and the vapor pressure of the pure solvent is comparatively more. And if I say that the vapor pressure of solution is given by a symbol that is called as PS, then here I can say that P01 is greater as compared to PS, where P01 is the vapor pressure of the pure solvent and PS is the vapor pressure of the solution. It simply means that there is certainly a difference in the vapor pressure of the pure solvent and the solution, and this difference in the vapor pressure, or this difference between the vapor pressure of the pure solvent, that is P01, and the vapor pressure of the solution, that is PS, is called as the lowering of vapor pressure, given by a symbol that is delta P, and hence I say delta P is equals to P01 minus PS, the first formula which you're supposed to remember, that lowering of vapor pressure is given as delta P, which is equal to P01 minus PS. Once we know this, let us go to next one, that is relative lowering of VP. Now, relative lowering of VP, or relative lowering of vapor pressure for a solution, is nothing but first of all a ratio, and it's a ratio of lowering of vapor pressure of the solvent in the solution to that of the vapor pressure of the pure solvent, symbolically given as delta P, upon it is P01. So one thing we learned over here is lowering of VP, and second thing is relative lowering of VP. VP is nothing but vapor pressure. Let's try to understand a multiple choice question. 10 cc of a volatile liquid is added to a liter of water. The vapor pressure of water over the solution. Now, one thing is very clear: whenever you add a solute to solvent like water, in this case they are asking the vapor pressure of the water, meaning the vapor pressure of the solvent. The options are will be equal to that of pure water, B will be less than that of pure water, C will be greater than that of pure water, or will be very high. Now if you look at this thing, then this image or this particular screenshot says that whenever you add a solute, the vapor pressure of that entire solution will be less, first of all. And if I talk about the vapor pressure of the solvent in the solution, it is definitely less, because the number of particles of the solvent which is there on the surface is going to be less as compared to the pure solvent. So I can say that in this case the answer is CB, that is will be less than that of the pure water. That's all we have for this particular module. Thank you so much.